Hello everyone. Support us by liking the video and subscribing to the channel. Defects of vision and their correction. Vision or eyesight is the ability to see. This is possible when the retina of the eye focuses correctly on an object. When this is not possible, objects may seem blurred or distorted, which is known as a defect of vision. There are several causes of defects in vision. As shown in the diagram in figure, in an eye with no defects, the focal point falls on the retina. Focal point. The focal point can be defined as the point where light rays or waves meet after they have been reflected or refracted at the iris. Defects of vision and their correction. Myopia or short-sightedness. Myopia. Myopia is a defect of vision that affects a person's ability to see distant objects clearly. Those with myopia can see close objects clearly. This defect occurs when the focal point falls in front of the retina instead of on it. This can happen for two reasons. The first is the high converging power of the eye's lens. In this case, the ciliary muscles are not relaxed enough, which causes the lens to thin out and for the converging power to decrease. This causes blurry images of distant objects. The other factor is an irregularly long shape of the eyeball, causing the focal point to be in front of the retina instead of on it. This results in a higher distance between the retina and the eye lens, which means that the eye is unable to see distant objects clearly. They appear blurry because the image is out of focus due to the long distance between the retina and the focal point. Myopia or short-sightedness correction. Correcting myopia involves adjusting the distance of the distant object so it appears closer to the far point of the eye, which would allow the eye to see the object clearly. This can be achieved by utilizing a concave lens in front of the eye in the form of glasses or contact lenses. This involves divergence of the light rays coming from the distant object, so they appear to come from the eye's far point, which helps to increase the focal length. This is the distance between the center of the curved lens and the focal point. The concave lens decreases the converging power of the eye lens, forming the image of the object on the retina, as shown in figure 3. It illustrates that the image is created on the retina when the concave lenses are used compared to in front of the retina if the myopic eye is untreated. Defects of vision and their correction. Hypermetropia or farsightedness. Hypermetropia is a defect that affects the ability to see nearby objects while still being able to see distant objects clearly. The distant objects that can be seen are usually positioned more than 25 centimeters away from the eye. Hypermetropia can have two reasons. The first is low converging power. Here, the ciliary muscles are weakened and cannot thicken the eye lens when needed to increase its converging power. Hence, the image of close objects is formed behind the retina instead of on the retina. The other factor is the shape of the eyeball. When it is short, the retina is closer to the eye lens, causing the image of near objects to form behind the retina. See figure where the focal point is clearly behind the retina. Hypermetropia correction. By using convex lenses in front of the eye, the light rays from near objects converge through the lens, forming an image of the object close to the near point end of the eye. Depending on the power of the lens used, the converging power will be increased accordingly. Figure shows a diagram of the corrected hypermetropic eye using convex lenses. When utilizing convex lenses, the image is created on the retina instead of behind the retina, as was shown in figure 3. N is the normal near point of the eye, which is 25 centimeters, while N is the near point of a hypermetropic eye, which is more than 25 centimeters. Defects of vision and their correction. Astigmatism. Astigmatism is a common defect of vision caused by an uneven or asymmetric retina or focus of the eye or an irregular shape of the cornea of the eye. This causes some images to be sharper than others, as the rays that reflect from the object approach different points in the irregular or uneven eye. Astigmatism correction. Astigmatism can be corrected partially with cylindrical spectacles that oppose the irregularity of the eye. This means that if the refractive error of the eye is plus 1.5, the correction of the refractive error is minus 1.5. However, as the spectacles are fixed and the eyes move, the distance is always varying so that the vision is not totally corrected at all times. This problem is eliminated using contact lenses that are fixed on the eye. As they cover a large portion of the irregular cornea, they provide a total correction. Another option is laser correction, which uses laser technology to reshape an irregular cornea. This can also be used for other defects besides astigmatism. Defects of vision and their correction. Cataract. A cataract is a condition in which the vision becomes very blurry, almost cloud-like. It develops when a membrane is formed over the eye lens, which causes the vision to deteriorate over time. This condition may even lead to vision loss if left untreated. It can be treated surgically by removing the formed cloudy membrane and replacing it with an artificial lens. Defects of vision and their correction. Presbyopia. Presbyopia, which happens gradually as we age, is caused mainly in older people due to weakened ciliary muscles of the eye. The muscles lose their flexibility and thus are unable to focus properly on near objects. This defect can happen in conjunction with myopia, astigmatism, or hypermetropia. It affects the ability to see nearby objects. What is scattering of light? When sunlight enters the atmosphere of the Earth, the atoms and molecules of different gases present in the air absorb the light. Then these atoms re-emit light in all directions. This process is known as scattering of light. The atoms or particles that scatter light are called scatterers. Law of scattering. The intensity of scattered light is inversely proportional with the fourth power of the wavelength of the incident light when the particle, scatterer, is of smaller diameter than the wavelength of light. Applications of scattering in our daily life. Blue color of the sky. When sunlight enters the atmosphere, then it gets scattered. The wavelength of red light is the greatest and thus is scattered least. Violet rays are scattered the most, followed by blue, green, yellow, orange respectively. Our eye is more sensitive to the blue light, thus we see the sky as blue. Red sky and sun on the time of sunset or sunrise. At the time of sunrise or sunset, the position of the sun is very far away from the earth. The sunlight travels a longer distance through the atmosphere. Scattering blue light is more than red light. As a result, more red lights reach our eye than the blue light. Hence sunrise and sunset appear reddish. White color of clouds. The clouds are nearer to the Earth's surface and they contain dust particles and water molecules of a size bigger than the wavelength of visible light. These particles scatter all colors of incident white light from sun to the same extent, and hence when the scattered light reaches our eyes, the clouds are seen white. Atmospheric refraction. Atmospheric refraction, change in the direction of propagation of electromagnetic radiations or sound waves in traversing the atmosphere. Such changes are caused by gradients in the density of the air. What is refraction? When light travels from an area of one density to another, it changes speed. For example, visible light passing from air into glass is slowed down. Conversely, when moving from a higher density substance to a lower one, such as light leaving a glass lens and re-entering the air, it speeds up. This change in speed causes the path of the light to be bent or refracted. The amount of bending is governed by the refractive indices of both substances and what is known as Snell's law. The key points are: light entering or leaving a new medium perpendicular to its surface passes straight though without any deviation. Figure 1, ray A. At other angles the ray will be refracted, and the greater the angle of incidence the greater the amount of refraction. Figure 1, rays B and C. Notice how the light is bent towards the normal, green lines, on entering the glass and away from it on leaving. This is due to the glass having a higher refractive index than the surroundings and the resultant change in the light speed. The refractive index and hence amount of refraction is slightly different for different wavelengths, colors, of light, and consequently white light can be dispersed into its constituent colors to form a spectrum. Refraction of light in the atmosphere. Light entering a uniform medium such as glass is the simplest case. However, the atmosphere is much more complex. As light moves from the vacuum of outer space into the atmosphere, it encounters increasing atmospheric density and with it a changing refractive index. Consequently, as light passes through the atmosphere, the amount of refraction increases, causing the light to take on a curved path rather than a straight one, as is the case with a uniform medium such as glass. The schematic in figure shows rays of light from stars at different altitudes above the horizon passing through the atmosphere. The structure of the atmosphere has been very much simplified and the amount of refraction greatly exaggerated. Notice in particular the following. The light from star A, directly overhead, is not refracted and its light reaches the observer without any deviation to its path. The lower the altitude of a star, the greater the length of air it has to pass through. The lower the altitude of a star, the more obliquely its light strikes the atmosphere. These last 2 points combine to cause the amount of refraction to increase rapidly as an object approaches the horizon. As a result, star B appears at position B and star C is lifted to C.
I've been dreaming on in my head like I've seen it. A life worth living is a life with meaning. I'll do what I love till my heart stops beating. I'm feeding this demon.